Hola a todos! Hoy estamos mostrando.
Hello everyone, today we'll be talking about Internet of Things. We'll be showing how easy it is to get into it, and we'll be showing some examples of what can be achieved through it.
So what is the Internet of Things? The Internet of Things is a network of devices, vehicles and home appliances that are connected through a large network and they exchange data every second. Today we'll be focusing on Arduino, and the specific word we'll be using is the Arduino Uno. And we'll be using also some other production boards. Behind me, we have a picture of the Arduino, and now I will explain some of the things in this picture. This here is the power supply 5-volt input. This here are the power supply output pins. This here is the analog input-output. This here is the processor. This here is the LED diode. This here is the USB input, which we can connect our PC to it now. This here is the digital pin input, output also. And as you can see, the tilt on 3, 5, 6 are for what?
Pulse width modulation.
And now the main thing, this here red button is the reset button.
Thank you.
Thank you too. Now I will be showing you how to wire up the blinking example provided by the Arduino IDE.
The first example we're going to show is sort of the hello world of Arduino. It's called the blink example. So we have two functions which are called on start. In the setup function we define which pins we're going to use and how. Here we're going to use pin 13 as the output, which is where we're going to connect our LED, which is also the built-in LED for the Arduino. And in the loop function we define which code we expect the Arduino to execute over and over. Here we're going to use pin 13 we defined in setup. We're going to set it to high. We're going to wait 1 second, we're going to set it back to low, and we're going to wait another second, and that will be our whole loop function. Let's see it in action.
As you can see, simple as that. Now I will show you how to use pulse width modulation to achieve the fade effect.
In the next example we'll be demonstrating PWM or pulse width modulation. With this we can achieve the fade effect on the LED instead of only two states, on or off. First we'll define some variables we want to be stored outside of the loop. We want the LED on pin 9 because it supports PWM. Also, the brightness for the LEDs should be between 0 and 255, so initially we'll set it to 0. And the fade amount is how quickly we want the brightness to change. So on every iteration it will increase or decrease by 5. As before, we'll set up the setup function so that LED on pin 9 will be set to output. And in the loop function we'll have a similar setup, but we'll change some things. For example, we'll use analog write instead of digital write, so we can provide the voltage as well as the width of the signal. We'll increase the brightness by the fade amount on every iteration, and every time the brightness gets to the minimum or maximum, we will have to reset the fade amount, or in this case, switch it to a negative so that it goes back to 0 or goes back to the max, depending on where it's at the moment. So we'll also set the delay to much quicker than a second. This time we'll use 30 milliseconds so we can see the fade amount faster. Alright.
As you can see, also simple as that.
Now, with the use of some sensors, we'll show you what you can achieve with the Arduino. Now we move on to a more involved example. First, we'll define some variables for easier code navigation. The sensors we use have 3 pins, and 2 of them are used to retrieve data, the trigger and echo pin. And we also use some LEDs for easier debugging. So just like before, in the setup function, we'll define our input and outputs. So we'll just use the variables we defined before. Also, we'll use the serial module for communicating to the computer. It's just a way to send data to the computer so you can use it. And now we'll define a sensor function. This is actually provided to us with the, it's pre-made and it's provided with the sensor, so we'll just copy it over. We don't have to worry about how it works. Then in the loop function, first we'll get the distances from each of the sensors. And we'll also get them every 10 milliseconds. The next step is to print out this data to the computer. We'll just print out the distance from the first sensor and the comma, then the distance from the second sensor and the new line. We'll also set some LEDs to high or low depending on how far away they are. We'll use the same code in our computer program. We'll code up just now. Now we're going to add some LEDs for some easier debugging. And this is the program we're going to run on the PC. The code you see already is just some ways of how to emulate keyboard presses. We're not going to worry about them now. All we have to do is use them properly, like the press and the release methods in our main function. As we said before, we'll just use the serial port to communicate with our Arduino. The COM6 port we defined here depends on your computer and which port is available. And we'll make sure the script runs indefinitely. Now we're going to parse the data the Arduino gives us. As we said, there's a comma in between the 2 values. We'll just put them in the first and second variables. And we're going to print them out for easier debugging. The sensors sometimes mess up and report 0 as value. In that case, we're just going to skip that iteration completely. And so we're just going to say if the distance is lower than 5, that means our hand is really close to the sensor, which means we're going to push the up arrow key. And if it's between 15 or 30, which means it's a bit back from the sensor, then we're going to press the back button. And if it's neither of those, if the hand is not on the sensor, we're going to release it. And we'll do the same for the left and right arrow keys for the second sensor. Let's copy this over to Visual Studio and try it out.
And now we are going to demonstrate what we made so far. Easy peasy lemon squeezy. Arduino review, Arduino review, Arduino review, Arduino review, Arduino review, Arduino review, Arduino review.